Good morning, everyone. Today we have to learning the data warehouse schemas and operations. Here we have two schemas. Here we have two schemas are star and snowflake and cubes. We have to discuss in the data schemas. First of all, we have to listening the schemas. We have to understanding the what are the fact table, what are the multi-dimension. We have to see the entire on the multi-dimension cubes. What are the data cube? We have to see that one. And operations. Here we have to seeing the four operations. First one is roll up. Another name we have to calling the deal up, down. This is one of the operation, and a slice and dice one operation, and priority is one operation. These are three operations we have to see on the operations on a cube. First of all, we have to see in the schemas. We have to see the what are the facts and what are the dimensions. We have to see that. Actually, we have to data is we have to representing some table format. Here we have to take in the multi-dimension data. We have to representing in a multi-dimension. We have to see in a example. Here we have to take in the analyzing some sales data. One dimension we have to take in the sales or a item 1, item 2, item 3 or S1, S2 we have to wish, and we have to take in the one other way we have to take in the location, another way we have to take in the time. These are we have to representing the multi-dimension. Here dimension means we have to take in collection of logical relative attributes for using for a modeling of the data. Here we have to take in the some collection of data based upon some attributes we have to use for a modeling of the data. This is of the dimension of data. We have to take in see that one. We have to take in the protect IDs, information, sales, store information. This is a one dimension tables. These are a dimension tables. This one entire we have to representing the one table, that is a fact table. Here fact table means we have to representing the numerical measurements or a quantity by which we have to analyzing the relationship between dimension. We have to understanding that one. Here we have to take in the fact means we have to take in the some numbering or some we have to take in the name. We have to analyze in the easy way. We have to analyze in the table. Between we have to take in the sales dimensions. Here dimension we have to take in the store information. Store information what are there here? Store code, store name, store capacity. These are a store information he kept. And information, time information. Time information having a time ID, time producing. These are a time information. These are a fact and a dimensional. Here we have to take that one. Here time is a containing a date, month, year. Okay, this is one dimension. Okay, store having a store ID, city, state, country, region. This is a one dimension. This way we have to representing of the dimensions. We have taken one store information. Store dimension having what are their total, region, district, stores. These are a one dimension station. Coming upon the schema, here we have to see that the schema means collection of database or a objects including the table, views, index. This are a we have to represent the schemas. Okay, here schemas having a two star schema, snowflake schema. Here we have to taking upon the some dimensional or a fact table we have to considering one. Here each dimension we have to represent the dimension table. Okay, we have to call in the dimension table. Here fact table. Fact table means we have we have to take in the numerically or some name. We have to analyzing the relation between the data. Okay, we have to analyzing the data. Here we have to fat table having a all dimension tables with a multiple joints. Okay, we have to connecting the tables with the help of the joints. Each tuple in a fat table consists of the pointing to uh, every dimension table. Here we have to taking the construction for a fat table. This fat table having a some attributes. This each fat table having a some dimensions. This dimension table and fat table we have to connecting to the with the help of the joints. This way we have to multiple joints are there. The link between fat table in the center. Okay, we have to represent the fat table as a center, and um, and we have to connecting to the dimension table. This are a schema. Coming upon the star schema, this is a star schema. Okay, the link between fat table in a center. Okay, we have to take in the fat table have a center, and the dimension tables we have to connecting to the with the help of the fat table. We have to see that the shape we have to coming upon the star schema. Okay, now this is one of the star schema type. We have to see that the fat table. This fat table having we have to considering the key 1, key 2, key 3, key 4 and column names. Here key 1 having a what are the dimensions here? Key 1 having a key 1 some attributes. Suppose we have to take in the company. Company having a some dimensions, sales, profit, salary. Okay, this one is dimensions. Here company having a some book. This way we have to start schema. Here what are the advantages of the start schema having? This one we have to see that one. Example, sales having a protect code or PDL code, store code, union code, diamonds code, cost. This one we have the one of the fat table. This fat table having a multiple dimensions. Here store code having a store name, city, telephone, phone number, management. This is a one dimension table. And PDL, PDD. PDD we have to having the year, quarter, month, date, week. This is one of the dimensional. And protect having a description, color, size. This is one of the dimension table. This way is a star schema. We have to see that one relation table we have to construct in that one. Here relation table we have to then protect code having a this dimensions. This is one of the star schema with a sample data. Star schema is a which one we have to modeling for a relationship, one to many relationship between dimension table to fact table. Okay, we have to relation between the one to many. Here we have to take in the one single fact table. We have to take in the multiple of the dimension tables. This order of question. Here fact table having a primary key has only one key column per a dimensions. Okay, this is one of the fact table star schema points, and here to seeing that one advantages of the schema star schema: simplest and easily, and the optimization navigation of. Here we have to this is the advantages of the simplest to easily we have to analyzing the star schema, and most suitable for a query processing. These are of the advantages of the star. Next one is the snowflake schema. Here this is a one of the type of the star schema, but we have to use some complexity of the this one data more. Here snowflakes is a variable of we have to take in the coming upon the star schema, but we have to take in the multi-levels of the multi-level of the dimension tables. Here we have to follow the normalization of dimension table in a star schema. Here we have to normalization, we have to in normalization process we have to elimination of the reductions. In this way we have to reduction we have to follow. We have to see that one example. First we have to see that one. Here we have to take in the one fact table. protect key, time key, customer key. Here every protect key having a dimension. Here this dimension having a some dimension band key. This diamond band key having a category key. This is a one dimension. This means of the level by level we have to increase in the key. This is one of the multi-dimension processing. This is of the snowflake schema. Here we have to, this is one of the linking, we have to linking of the nation. The attributes, we have to separating tables. We have the new tables linking back to the original dimension table. This is of the snowflake. What are the advantages here? We have to see that less reduction due to the normalization dimension table. Here we have to less redirection from of the normalization. Next advantages is a dimension table are easy to updating. This is one of the examples. Advantages and disadvantages having a, we have to see that one we have to see the many complexity of the there, many complexity of the there. And with up to second example, we have to connecting with is a more than number of the joints we have to using increasing. This is one of the disadvantages. To browsing to content difficult to handling this one. Next we have to see the operations. We have to see the operation. First of all, understanding the cube. Here cube we have to following the some data structure for quickly analyzing the data. Here we have to see the operations, roll up and drill down. Okay. Next one, we have to see the first example. We have to see the multi-dimension cube. In a multi-dimension cube, one dimension we have to see the days, day 1, day 2, we have to see that one. And one dimension we have to see the P1 and P2, protect ID, protect 1. And one dimension we have to see the S1, S2, S3. These are 3 dimensions we have there, and means of the stored IDs to store 1, store 2, store 3. This is of the data cube example. We have to see the one first of roll up operation. First operation is a roll up. Here roll up we have to use the concept of the, we have to follow the some hierarchical process. It is one of the high data abstraction. We have to see that one example. Here we have to take in the days, protect and a sum. We have to take in the sales S1, S2 and sum. Here we have to do the roll up, means we have to computing the sum. Roll up means we have to take in the day 1, day 2 addition. Okay, day 1, day 2 addition. This is of the roll up. And we have to do the drill up. Drill up means we have to doing the drill down. We have to doing the reverse of the roll up operation. Then we have to see the backward. This is the, we have to see the day 1. Day 1, what are the day 1 sum? We have to do the reverse of the roll up. Next one is a slicing. Next one is a slicing. Here slicing we have to, data cube is a sliced. We have to take in the one dimension. Here we have to we have to take in the day 1 cube. We have to P1, P2, S1, S2, S3. This means we have to divisioning of the some new cube. And multi-dimension we have to take in the multi-dimension cube. We have to do the on a slicing operation. This slicing operation we have to creating a new cube. Here we have to take in the day 1 cube. With respect of the day 1, we have to division of the P1, P2, S1, S2, S3. This is one of the slicing. These are the operations on the cube, and we have to also see the schemas of the data warehouse. Thank you everyone.